What's up, guys? My name's Rishi and I'm a programmer on FTC team brute force team 19838, and today I'm going to be showing you a basic tutorial for creating your first driver mode teleop program to use on your robot. Now right now I'm using Visual Studio, which is a code editor, which is where I'm going to be putting all of my code, and it's going to be written in Java. You can take this code and you can put it on your Rev hardware client if you use onbot Java, which is what we use. Maybe you use blocks. You can try and change the logic from this into blocks, or maybe you use Android Studio and you can directly take the code straight from here and put it in your program. Either way, all link to the code will be in the description on our repository in GitHub. So let's start off. What I've done so far is I've created 3 different files. We have our autonomous file, our teleop file, and our utilities file. And essentially with all 3 of these files, we hold each of our separate programs in here. So far I have our driver mode program and then our utilities file, which is where we're going to be putting all of our functions. So let's get started by first getting our packages and importing all of our files into driver mode. So what we're first going to do is we're going to create a package in driver mode, and we're going to call this first inspires.ftc.robot, and then this is a teleop program. So that will be our first line to identify the file and the package of what this program is actually is. So next we're going to import some essential things which we need for our program. First we're going to import something from Qualcomm, and Qualcomm essentially holds all of our, or most of our imports, which we're going to be using throughout the video. So since this is a linear op mode, we're going to be importing this. We're also going to be importing the blinker, which is the light on your control hub, and I'm going to copy over a few others which we're going to be needing. So the ones that I copied were, in case we have a continuous rotation servo, the gyroscope, which is on our control hub. If we have any color sensors, any servos, any touch sensors, then obviously we upload all the stuff needed for the teleop in case we want to disable anything. And then we have our actual motor itself, as well as some elapsed time to work with. We also want to import some other things which will help us with debugging, such as the robot logs so that we can log stuff onto our log file, telemetry so that we can display things on the driver controller, and a voltage sensor in case we want to show the voltage of the battery. So now let's start with the actual program. Since this is a teleop program, we're going to put an @teleop, and we're going to call this a class called driver mode. And this will obviously extend to the linear op mode which we imported earlier. So now that we've created our class, we can actually get to the first part of the program. So essentially what we're going to be making is we're going to want to make just simple movements, right? Moving forward, moving backward, strafing right, strafing left, and rotating right and rotating left. So in order to do that, we're going to have to put all of our joysticks. So the first thing we're going to do is we're going to create variables or doubles for each of our controllers. So we have our right stick Y on gamepad 1, and we're going to set this to 0. So this is going to be our right stick Y, and I'm just going to label this create variables for the joysticks, and we're going to put our right stick Y, our right stick X, and the 1 is just to signify which controller in case you have more than one controller, which you probably do. Obviously we have our left stick Y, our left stick X, And then that's basically it, and in case you have a second controller, we just copy and paste this. So now that we've created all of our variables or placeholders, we can put at override to override anything, and then create our function, which is actually going to run the op mode. So at the start of the op mode, the first thing we're going to want to do is we're going to put a wait for start command, and this wait for start command is going to wait until start is pressed on your driver hub. And after waiting until start is pressed on your driver hub, so after wait for start has been initialized, then we're going to actually start the op mode. So we're going to put a while loop, and this while loop is going to be while our op mode is active. We are, firstly, the first thing we're going to want to do in this while loop is we're going to want to assign all of our variables up here to the actual controller values. So we can just copy and paste them, make sure we get the tabbing right, and then instead of setting them to 0, we're actually going to set them to this dot gamepad1 dot right stick y. And now all we have to do is just copy and paste this. And just label it. So right stick X, left stick Y, left stick X, and then gamepad 2 right stick Y, gamepad 2 right stick X, Alright, so now that we have all of our variables assigned to our joysticks, we can actually get started with the program itself. So what we're going to do is we're first going to get an if loop, and in this if loop we're going to say that if right stick Y is greater than 0, and here's the thing about these joysticks, right? They're really weird in the sense that when the joystick is up is at -1, and when it is down it is at +1. So when the right stick Y is greater than 0, the joystick is actually pointed down, which is why we actually want the robot to move backward. I'm not going to actually put the code because I'm going to show you a different way of implementing the code than usual. But we're going to create another if statement, and we're going to say if right stick Y is less than 0, which means it's moving up, then we want the robot to move forward. So after we have the backward and forward movements programmed, we're going to want to put the strafe. So for the strafe, we'll put the strafe on the right stick X. Oh, I forgot to put all the 1s over here. So we'll put it on the right stick X. If this is greater than 0, then the robot will strafe right. And the way strafing works, or the horizontal, when the joystick is right, it is at +1, and when is left, it is at -1. So right stick, and then when right stick, forgot to put an if here, when right stick X is less than 0, we're going to strafe left. And then lastly, we have our rotation. Let's put the rotation on the other joysticks. Let's put it on the X control. So on our left stick X controller, if that's greater than 0, we're going to want to turn right, and then finally, if our left stick X1 is less than 0, we're going to want to turn left. So now we have our basic if loop for our movement. So we're almost done here. The last thing we have to do is actually get our robot to move. So here we have our utilities part. And essentially what we're going to do is we're going to start off by naming the package, obviously. And we're going to name it org.firstinspires.ftc.robot.utilities. And we're going to import, I'm just going to copy and paste these imports. Alright. I think it's most of them. Yep. So we got our DC motor, robot log, all that stuff. And now we're going to create the class, so public class robot. And we are going to define all of our variables. So first we're going to have our private variable. We're going to have the blinker, which is going to be our control hub. And then if you have an expansion hub, it's also going to be under the blinker class, and it's going to be an expansion hub. We're going to initialize our IMU, which we will be using later. And then we have our actual motors. So our DC motor, I'm going to call it front left. Going to copy and paste this. Call this our front right wheel, our back left wheel, and our back right wheel. And after we have all of our wheels, that's mostly it for our variables. So what's next is we are going to want to create our hardware map, which is where we're going to find everything on our configuration file, and we're going to extract it into our robot. So we're going to call this public robot, and we're going to put the hardware map here, hardware map. And then what we're going to do here is we're going to first find the IMU. I'm just going to copy and paste this part to make it easier for me. We have our IMU control hub, expansion hub, and then I will do the back left, which is going to be hardware map dot get. It's going to be a DC motor dot class, and then we're going to put whatever in our configuration file, and our configuration file just names it back left. Now I'm going to copy over our back right, and then I'm going to take our front left and front right as well. So now that we have our hardware map, we now have all of our variables here, and they're initialized, they're ready to go. So now all that's left is to actually create our functions to move forward and move backward, stuff like that. So first, let's create a function to move vertically, which is going to be moving forward and backward. So let's call this public void. Then we're going to want to move vertical, and this will take an input of a number called n. And what we're going to go from here is we're going to take our front left dot set power, and we're going to set the power to n. And then we're just going to copy and paste this. We want to set our front right, our back left, and our back right. And here's the thing, we use Go Build a Mechanism wheels, so if you don't use mechanism wheels, this is going to be different for you. But if you're using mechanism wheels, in order to go forward, the first motor needs to be set to a positive value, the second motor is going to be a negative value, third motor is going to be positive, and then the fourth motor is going to be negative. Obviously assuming that you have it in the front left, front right, back left, and back right configuration. So that's what it's going to look like for us. If the value inputted is negative, it'll just swap all these values and it'll make the robot move backward. So we have our move vertical function. Now next, let's put our move horizontal function in. So for our move horizontal function, let's call it public void move horizontal, and then we'll input n again. And here we're going to follow a similar method to our first one, except this time in order to strafe, we're going to need the first two values to be negative and the second two to be positive, and then this will flip for left and right. And also, if these numbers are too fast, you're like, whoa, this is going way too fast, all you have to do is multiply n by a certain number. So at the very start, let's say my strafe was moving a bit too fast. I can just take n, and I can say that n is now equal to n times 0.5. So it'll take the variable and it'll half it. So that way, when you have the joystick all the way up, it'll actually only be moving at half speed. And now all that's left is to define our rotate. So let's call the function rotate. It'll also take n. And for rotate, it's almost going to be the exact same thing, except the way rotate works is all of our motors are going to be set to either all negative or all positive to rotate left and right. So now that we have all of our three main functions defined, we can go back to our driver mode, and all we have to do is just plug these in. So all we have to do is just... Oh, I almost forgot a really important part. So obviously, all of our functions are defined here, and we can't just call them in here without actually importing our code. So what we're going to do is we're going to import org.first.inspires.ftc.robot.utilities.robot. So essentially what we're doing here is we're taking this package, which is the name of the program, and we're just importing it into here. That way we can actually use all the functions that are called from here straight into here. Alright, so let's move on. The next step which we're going to want to do is we have to get our hardware map into the program. So right after the run op mode function, we're going to put our robot, and we're going to call it robot, and this is going to be our new robot hardware map. And this will give us access to our hardware map. So finally, all that's left to do is simply get our functions from there and input it into our driver mode. So what we're going to want to do is we're going to want to call robot dot our move vertical function, and we're just going to input the output of our controller. And we can copy and paste this since it's the exact same thing for moving forward. For strafing right, we're going to want to move horizontal, and it's going to be RSX1 that we're inputting instead. Just copy and paste erase this and put it over here. And then lastly, we're going to want to rotate. Here we just plug in our LSX value over here. And now you have officially completed your first simple driver mode program that will run your robot to move backward, forward, strafe left, strafe right, and turn left and turn right. If you have any comments about the code, or if I make any updates to the code, then just let me know in the comment section down below. And check the description if you want to see all of these files on GitHub. I'll put the link on there in this public repository. And I will see you guys later.